Hey, this is your skill check number 4, chapter 7, linear regression. The scenario, the following is real data, although the scenario is made up. So we imagine that the chief medical director at New Amsterdam Public Hospital, Dr. Max Goodwin, wanted to see whether there is a relationship between a person's percentage body fat and their age. So he collected data. X is the age, that's the predictor or independent variable, and Y is the percent body fat, that's the response or dependent variable, from 250 randomly selected adult patients. So first of all, how would you describe the association between age and percent body fat? Looking at the scatter plot, we need to judge whether there's a linear or nonlinear trend, whether that trend is weak or strong, and whether it is positive or negative. Here, there is clear evidence of a linear trend such that as age increases, the percent body fat increases in a linear fashion. So linear trend, but it's very weak because there's a lot of scatter in this data. And the slope of the trend is positive. Next question, we're going to write down the equation for the regression line, otherwise known as the line of best fit. And then we're going to provide an interpretation of the model coefficient. So here we have a table that resembles the kind of table that you would see in Minitab output. The constant is the intercept, B0, and the variable with a name that corresponds to the name of the predictor variable, that is the slope. So the equation for the line of best fit looks like this. It has a B0, it has a B1, and we just need to put those numbers into the appropriate place. In this scenario, to interpret the intercept, we know in general the intercept predicts the average response when the predictor is equal to 0, when the x is equal to 0. In this case, we could say that the intercept predicts the percent body fat for infants, that is, for people whose age is 0 years. You see, when you put 0 in for x, you get y hat is just equal to 10.35. So it predicts that the percent body fat for infants to be 10.35% on average. However, the intercept should not be interpreted in this case because x equals 0 falls outside the range of the data that was used to fit the model. The model, in fact, is only valid for ages between 22 and 81. You can see that in the scatter plot. The youngest age in the data set is 21 years, and the oldest age is 81. Did I say 21? I think I meant 22. Yes, 22. So 22 to 81. So we can't make any predictions outside of that range. If we were to do so, that would be called extrapolation. We are not supposed to extrapolate. Now, what about the slope? Well, we have in this picture here, we can draw a little triangle which shows us that for every 1 year a person grows, every extra 1 year of age, the percent body fat on average will increase by 0.1934%. So for example, it would take about 5 years, according to this model, for body fat to increase by 1%. Right, so here again, the slope predicts that the percent body fat of people between ages 22 and 81 increases by 0.1934% per year on average. So here we're going to use the model to predict the percent body fat of a person who is 61 years of age. So here's our model equation. We put 61 where we see x. We first multiply, and then we add, and we get a total of 22.1474% body fat. So what we're saying is, for all the population of people who are 61 years, the average percent body fat we predict to be 22.1474%. So that is a prediction for an average person. Now, if Chilo is 61 years old with a percent body fat of 11.8, what is the residual for Chilo? So just reminding ourselves, the fitted value for a person who's 61 is this number, 22.1474%. A residual is just the difference between what was observed and what would be predicted. So here we subtract from the observed value of 11.8%, we subtract 22.1%, we get minus 10.3%. So just to clarify, the model predicts that the average 61-year-old person will have about 22.15% body fat. Why is Chilo's percent body fat only 11.8? Because any individual person will almost certainly have a different percent body fat due to individual differences. So we expect that any individual person will be different than what you expect to see on average. Here we're looking at the residual. So on the horizontal axis, it's the fitted value. On the vertical axis, the standardized residuals. We need to see two things. One, we need to see that there is no trend of any kind in the residual, linear or otherwise. We also need to see that the spread in the vertical direction is about the same as you move from left to right. If these two conditions hold, then according to the linear enough condition and the thickening of the plot condition, we are okay. One might also test to see if the distribution of the residuals is consistent with a normal distribution, but for this skill check, I did not include that. Here, remind yourselves that the linear enough condition says if there is any linear or nonlinear trend in the residual versus fits, then the regression model is not appropriate. Here, the linear enough condition is met because there is no trend of any kind in these residuals. Now, another way to think about this is if we go back to the plot of age versus percent body fat, what the linear enough condition really means is that the linear trend that we see in the scatter plot is linear enough to justify using a regression model in the first place. So we test the linear enough condition by looking at the residuals. But what it really means is, yes, there actually is a linear trend in that original scatter plot, in this case, age versus percent body fat. Checking the thickening of the plot condition. If there is thickening of the plot in the residuals versus fits, then the regression model is not appropriate. Here, the thickening of the plot condition is met because the spread of the residuals in the vertical direction is roughly the same as you move from left to right. Now again, we use the residuals to test this condition, but what it really means is if you look at that original scatter plot, age versus percent body fat, and if you look at that line of best fit, then the spread about that line is roughly the same for all ages starting at 22 and going to 81. And so that's it. If you have any questions, leave a comment. You can ask me in class, send me an email, as you wish. Bye for now.